When you hear the word physics, the first word you think of might not be fun or interesting, but I assure you that physics can be exactly that. The topic of black holes has been debated for decades, and is still very unclear, as it is nearly impossible for us to conduct any thorough research on them. It is clear, however, that a black hole is a celestial body with a gravitational force that exceeds anything else. Therefore, in order to comprehend what a black hole is, you must be able to understand what gravity is. Gravity is a force that pulls everything together. A force illustrated by the equation F equals G times m1 times m2 divided by r squared. In this case, F is the force of gravity, G is the universal gravitational constant found to be about 6.67 times 10 to the negative 11 newtons times meters divided by kilograms squared. m1 and m2 are the masses of the two objects, and r is the distance between the centers of the two objects. From this equation, we can conclude that as the masses increase, the gravitational force increases, and as the masses decrease, the gravitational force decreases respectively. Also, as the distance between the two objects increases, the gravity decreases rather quickly. This formula works for all objects, but gravity is a weak force compared to other forces, which is why the universe isn't all clumped into one area. The only reason why we are pulled to the Earth is because of its immense mass relative to us. From this information, we know that gravity is escapable if something is traveling faster than the gravitational force of the object. This is known as the escape velocity, which is described by the equation v sub e equals the square root of 2gm divided by r, with v sub e being the escape velocity, g being the gravitational constant I mentioned earlier, m being the mass of the object you are trying to escape, and r being the radius of the object. For the Earth, you would have to travel at about 11,000 kilometers per second in order to escape its gravity. This is, of course, if you were to ignore factors such as air friction and assume that a vacuum of space surrounded the Earth. It is important to keep in mind that the larger the density of an object, the larger the escape velocity is. If you shrink the radius of an object to be so small that even the speed of light could not surpass the escape velocity, then you have a black hole. Light is not reflected so we can see it, but absorbed by it, making it invisible, which is why we call it a black hole. In this case, you would have to make the Earth have a radius of about 8.7 millimeters. The radius that you would have to collapse an object to become a black hole is known as the Schwarzschild radius. So if we cannot make black holes, how are they formed? Well, it is important to note that there are different kinds of black holes: stellar black holes and supermassive black holes. Stellar black holes are formed when a supermassive star, about 20 times the mass of our Sun, collapses. When a star is still living, nuclear fusion, a process where the nuclei of atoms collide at high speeds to form new nuclei, balances the outward pressure of gravity. When it no longer has enough atoms to combine, it can no longer overcome its own gravity and collapses into a singularity, a point with an infinitely small area and an infinitely large mass. A small star around the mass of our Sun may collapse into a white dwarf, which is a star remnant about the size of Earth that emits faint white light. A white dwarf does not keep collapsing because the electrons in the star do not like being too close to each other. A larger star collapses into a neutron star. In this scenario, the gravity pushes the star tightly due to the larger mass, causing the protons and the electrons to turn into neutrons and neutrinos. The neutrons prevent the star from collapsing further. Although it is uncertain as to how a supermassive or primordial black hole was formed, I believe that it originated from the Big Bang, when all matter and energy was created, as they are the center of galaxies and keep them intact. Some people may think that black holes are some sort of terrible object that greedily engulfs everything, but they are not so. For example, if the Sun were to suddenly become a black hole with the same mass, which will not happen as it is not massive enough, the Earth's orbit around it would be the same as it is now, then we would die from the lack of sunlight. This is because the Earth would be a safe enough distance from the black hole. In fact, you can escape a black hole's pull as long as you have not passed the black hole's event horizon, or the distance from the center of the black hole, the singularity, to the area where the escape velocity is equal to the speed of light. This is also known as the Schwarzschild radius, or the point of no return. A big contribution to black holes would probably go to Albert Einstein for developing the general theory of relativity, which states that gravity-massive objects cause distortions in space-time. A combination of time and space is one, that is felt as gravity. Black holes are thought to be able to bend time and space in this way, but Albert Einstein resisted the idea that black holes existed. So why do we think they exist today? Although black holes may be invisible, they are not unnoticed. One of the ways scientists can detect where black holes may be is if some objects, such as gases, orbit something we cannot see. Also, black holes may sometimes emit X-rays, Before matter falls into a black hole, it may disk around it, growing very hot and ricocheting particles into space where we can detect it. What happens if you were to fall into a black hole feet first? In this scenario, something very interesting occurs. The force of gravity at your feet is so much stronger than it is at your head because the distance from your feet to your head is so great relative to the size of the black hole, causing your feet to fall faster than your head, making you stretch so much that your molecules no longer hold together. But that's not all. The fabric of space-time funnels into the black hole, making the space you occupy above it more than it is by the black hole. The result is that you get squeezed like toothpaste from a tube. This process is called spaghettification. The problem with black holes is the number of contradictions that arise if they were to exist. For example, there is a rule that on the atomic level, there's always a tiny amount of activity, yet it is said that nothing exists at the edge of the black hole. This brings us to Stephen Hawking's theory of Hawking radiation. In order to understand Hawking radiation, you need to understand what antiparticles are. Antiparticles are particles with the same mass and spin as regular particles, but with the opposite charge. When an antiparticle collides with its equal counterpart, they annihilate each other, releasing energy as photons and neutrinos. When this occurs at the event horizon, an interesting thing happens. The positively massed particle would have just enough energy to escape, while the negatively massed particle would fall into it, decreasing the mass of the black hole. Observers would be able to see the positively massed particles as radiation, named Hawking radiation. Because the antimatter is swallowed, this is why I think there is more matter in our universe than antimatter, despite them being equal to each other. I like to think of it this way. If you were to fill every black hole with all the matter and antimatter in the world, it would be just enough to cancel out, leaving a vacuum in space. There are many theories about what goes on in a black hole. For example, some scientists believe that the black holes could be some sort of a cosmic portal attached to wormholes and leading out of white holes, which are thought to expel matter. Because of the ripple in space-time, some people believe that it's possible to turn up in a different part of the universe, at a different time, and maybe even another dimension. Some people even think that we could one day use this for human travel, though many are skeptical. I also say that we should not attempt to do so. Let's face it, not everything in the universe is for our use. Another theory is that our universe is in a black hole of a larger universe, and we are just one of many, and the black holes in our universe lead to other smaller universes, like a fractal. Chances are, humans just aren't meant to understand what these mysterious objects really are, and researching them will be extremely hard. If we are meant to grasp the secret of these celestial bodies, it will be up to you to delve deeper into this topic. Why should you care? Well, for starters, without them, galaxies probably wouldn't exist. Also, studying black holes will help us understand the nature of our real universe, as they represent matter and energy in their purest forms.